Good evening and welcome to an environmental engineering special. Today's topic, the chemical compound methane. Methane gas is composed of one carbon atom surrounded by 4 hydrogen atoms. The problem with methane gas is that it is a greenhouse gas, which means it's trapped by Earth's atmosphere and heats up the planet. Around 60% of all methane emissions are due to human factors, meaning that a reduction in methane gas is feasible and approachable by scientists. The 3 main ways that us humans release methane into the atmosphere is through energy sources, waste management, and agricultural sources. And it is just our luck that we have 4 people coming to talk about these 3 topics today. Our first speaker will dive into the methane production caused by energy sources.
How did that happen? I'll tell you, Bob. Energy. It's all around us. Thank you for having me today. My name is Dr. Ethan Easthup. I'm the lead executive director, CEO, president here at ExxonMobil. I've worked at many different companies in the energy sector, and sadly to say, when it comes to methane emissions, the energy sector accounts for the second most. 85% out of that comes directly from oil and natural gas production. So I'm going to play this tape behind me of something that we do not like to see. That's an oil rig on fire. That's not good. That's a lot. That's a lot of stuff happening right there. Out of the other 15% comes approximately just from coal and mining and production of other natural gases and materials. But here at ExxonMobil, we take pride in the fact that we're trying to really hunker down and detect and control these things before they happen. So a little bit about that. Right now, we have approximately 52 satellites orbiting, and they are creating 3D models that will detect and kind of map out on a large scale these methane emissions so we can really track where it's coming from. Around us in the air, we have LiDAR that will detect leaks, and that allows us to get to those leaks faster. And then just on a ground level every day, we have different procedures in place that will allow us to mine or to extract these natural gases at a certain ratio. And we have lab work that's being done to really learn how to contain the methane emissions once they are released. Sadly, it is just a part of the game. But here in the U.S. and especially around the world, energy is a big driving factor in a lot of things, but let's just hope we keep it clean. Thank you, Bob.
Wow, can you believe that's what energy sources do to our atmosphere? Now let's take a look at the waste management side of methane gas production.
Thank you for having me. My name is Dr. Smith. Today we'll be discussing methane emissions in our waste industries, but to be a little more specific, I'll be diving into methane emissions in our municipal solid waste landfills. A couple facts I want to key in on is that the average person in the U.S. produces about 4.9 pounds of trash per day. We have reports dating back to 2018 that an estimated 240.3 million tons of trash is produced per year. Of these amounts, around 50% of them get deposited into our landfills, which is a normal process. But unfortunately, after this trash sits there for about a year or so, methane-producing bacteria begin to decompose it and break it down. And during these processes, an unfortunate byproduct is these methane gases, which gets produced or emitted into our atmosphere in alarming amounts so high that it actually takes up or makes up about a third of all methane contributions in the U.S. A couple countermeasures that industries have been looking into to reduce this amount is collection systems that are now beginning to be implemented into these facilities that now collect these emissions and convert them into renewable energy. As well on the industry side, on the lower level, people like me and you I know you guys have heard about it, but keeping green, composting, recycling, they actually do play an important role in reducing these emissions. I would like to point out that in certain cities, they've seen emission reduction of about 84%. So I truly believe that if I play my role, you play your role, and we trust these industries to be more healthy, be more green, we can begin to start seeing an immense reduction in these amounts of methane being produced. So thank you guys for having me. Have a good one.
Wow, that was a great insight to the waste management side of methane production. Now let's take a look at a video covering the agricultural side of methane gas production.
Methane gas can be produced by cows and bogs. This is due to the bacteria found in their digestive tract. Each time a cow passes gas or burps, a small amount of methane is released into the Earth's atmosphere. Prior to industrial farming, this may not have been an issue, but there are roughly 1.4 billion cattle in the world, with the number growing due to the rise in beef and dairy demands. Along with other grazing animals, cows contribute about 31% of the annual methane budget in the United States. The question is, how do we plan to counter the agricultural production of methane in the United States and around the world? Researchers claim that we need to rethink our approach to agricultural and livestock production. This includes new technology, alternative sources of protein, and embracing plant-rich diets. Farmers can provide their livestock with a more nutritious feed, while scientists are working on alternative forms of feed that reduce an animal's methane production.
And finally, we'll talk about the result of all this methane gas production.
Thank you for having me on today. My name is Andrew James, and now that my coworkers have given you some of the main causes and solutions of methane pollution, I'm going to tell you a little bit about the potential effects if we were to put some of these methane removal techniques into place. So a study was done by the Royal Society that identifies and quantifies some of the possible outcomes if we were able to decrease methane pollution through these removal techniques. The study considers many different variables. The researchers created sets of scenarios where they varied either the amount of methane removed or the timing of the removal to see its environmental effect. They found that under high emissions, the analysis showed a 40% reduction in global methane emission and also a temperature reduction of 0.4 degrees Celsius by 2050. Atmospheric methane is arguably regarded as the second most important greenhouse gas after carbon dioxide, and it has been steadily increasing at a rate of 8 parts per billion per year over the last 5 years. And people don't seem to mind. These increases have been driven primarily by the things that my colleagues just talked about, these being waste management, energy sources, and agricultural sources. Now, there's way more going on in all of these different areas, and we don't have enough time to cover it all today. But if you want to learn more, I encourage you to find the study by the Royal Society and do your own research and take a look at exactly how they came up with their conclusions. Now, I'll warn you, there's a whole lot of calculations and science and math that goes into it, but the main point is this. Taking methane pollution out of our atmosphere is worth the time and the resources, and quite frankly, we haven't been doing enough to stop it. That's all I've got. Back to you.
Well, that's all the time we have. Tune in next week where we won't be talking about cows farting.